So up till now we were studying the concept of SQL. There is latest concept that is for NoSQL as well. So NoSQL means not only SQL. So often big data frameworks associated with NoSQL database system. NoSQL, you cannot say that this is rejection or we don't have to use SQL anymore. But there are multiple examples or multiple differences between SQL and NoSQL. So it is designed to be non-relational, it is designed to be distributed, and it is designed to be open source and horizontally scalable. Usually don't require, so in NoSQL, if you have worked in SQL, you know that you have to first work on ERD and then you have to design a schema. So things are pretty much you have to define upfront and then go to physical installation of DBMS and then work on DBMS. So this usually do not require a fixed schema, and they do not also use join. So everything is done kind of in one table or in one record. So a common feature of NoSQL databases is that data is automatically distributed to new machines when they are added to clusters, and consistency is not enforced across these entities. So there are three main differences. One is data model. It lets you build data application without having to define schema first. Data structure, designed to handle unstructured data such as text, social media, posts. Development model. NoSQL databases are open source, whereas relational databases are typically closed source. With license fees, normally you have to pay them. So the history of NoSQL is that it started mainly in 1970 to 2000. That was the era when mainly RDBMS were working. So 2000 to 2005, new scale solutions were coming from Google, Facebook, Amazon. 2005 to 10, new open source mainstream databases were MongoDB, CloudDB, Neo4j, and 2010, adoption of cloud database system, IBM Cloud and Amazon DynamoDB. So what is wrong with RDBMS? So one size fits all, no. Rigid schema design, harder to scale, replication consistency is an issue. Joins across multiple nodes is hard. You have to combine 2, 3, or 4 tables, so that takes a lot of time, and also you need to have expertise to work on the join. So how does RDBMS handle data growth? So it is very hard and expensive. So non-standard query language, NoSQL has a non-standard query language. As a result of that, not following asset properties, there is a weaker control over consistencies, and integrity problem, ensuring that the integrity of data requires extra programming manually and is not the function of DB. So you cannot say SQL is perfect or NoSQL is perfect. Both SQL and NoSQL have their own pros and cons. So you have to decide whichever technique you are using has less of the issues, or also depend on the scenario that you are using for. So we need to know about the degree of integrity and consistency required, nature of data, types of operations, desired scalability, operations that are to be done, concurrence, volume of the data. So the focus of NoSQL is to provide three things: scalability, performance, and high availability. So these are advantages of NoSQL database: flexible schema, quicker, easier to set up, massive scalability, eventually consistency. The CAP theorem, there are three properties of a system: consistency, availability, and partition. CAP theorem, you can have at most two of these three properties. So either you will have consistency and availability, and partition won't be there. So you will have two out of these three things. NoSQL database systems offer base properties instead of asset properties. So base properties are basically available. Nodes in distributed environment can go down, but the whole system shouldn't be affected. Soft state, the state of the system and the data changes over the time. Eventually consistency. Given enough time, the data will be consistent across different distributed streams. So majority have their roots in open source community. Many have been used and leveraged in an open source manner. So there are multiple NoSQL databases which are open source. NoSQL, you have query language other than SQL, fast performance, horizontally scalable, no joins support, no complex transaction support, and no constraint support. So when you have to use NoSQL system, and the ability to store and retrieve great quantities of data is important. Storing relationship between the element is not important. Dealing with a growing list of elements, the data is not structured. Prototypes or fast application needs to be developed, and constraints and validation logic is not required. When you have to use complex transaction, joins, and validation. So there are basically four categories of NoSQL. First is key value, then is document, then is column family, and graph database. Key value database, these are the least complex databases. These are represented as hash map. They are ideal for basic thread operation. They scale well, and they can be shared easily. They are not suitable for complex queries and lack flexible data indexing and queuing. So for like key value are like first name Fred, last name Flintstone, location Bedrock. So these if you have worked with JSON, you will be familiar with the concept of key value pairs. So use cases, quick CRUD operation, create, retrieve, update, delete operations, storing in app, user profiles, shopping cart data. Non-suitable can be data connected with many-to-many relationships, social network, recommendation engine. So for that, it is not suitable. So examples are Amazon, DynamoDB, Oracle, Redis. So these are multiple databases that use this technology. So document stored database. So this is the format is normally JSON. In some cases, you can use XML as well. There is no predefined schema. The elements of the data are stored in documents. A collection can have indeterminate number of documents. Collection are like tables, and each document can have different fields. So the structure is basically key value pair. So most common data model or database example for this is MongoDB, CouchDB, and SimpleDB. So this is an example of MongoDB. So you have like this key, and you have a document here. So you have type, name, mood, birth date. So you have something like this. This will be in relational database, and this is in traditional or non-traditional NoSQL. So this is basically suitable for event logging and online logs, and unsuitable normally when you have multiple transactions. So examples, as we discussed, MongoDB, Cloud and CouchDB, Couchbase, so multiple databases which use document structure. MongoDB is normally used for electronic e-commerce, games, mobile application, operational data warehouse, content management system, agile development, real-time stats management. Column-based database being can the first person to mention it is not you can say transcendental role entity relational model towards the unified view of data. So you can have a column based NoSQL database as well, like if you have a row and you can have multiple columns against that. So for example, for record number one, we'll have uh, multiple skills. If we have row and skill, we have row as a student and column as a skill. So one student can have multiple skills. So this is basically column based NoSQL database. So larger data which is sparse, these database can handle being deployed across cluster of nodes, can be used for event like logging and logs, and not suitable for traditional asset transaction, and can be costly due to production timeline. So graph-based database, these are the most commonly used NoSQL databases. So graph contains set of vertices and a set of edges. Data models basically have nodes and edges. Nodes may have properties, edges may have labels or roles. These elements make direct reference to one another, and as such, a notion of join operation. So social network, communication network, computer networks, these all have graph structures. So example is Neo4j, OrientDB, Amazon Web Services. So multiple databases which are using graph database. So the common one is Neo4j. So Neo4j basically uses graphs to represent data and their relationship between them. Graph can be formed by vertices, edges, not directed graph, and directed graph. So one of the world's leading graph database, it is open source, high performance. Neo4j is stable. So it is under active development, high performance, and highly scalable. So Neo4j uses Cypher is a query language to populate database. It is written in Java. The protocol is HTTP REST. it has full asset conformance.